Hello everyone, I am Shreya Shukla. I am your TA for the course Structure, Form and Architecture, the Synergy. It is an NPTEL course. I would request all of you to please mute yourselves. Once I am done with the previous year questions, I will start with the Q&A round, and then you can ask your questions. You can type in the chat box, or at that time you can unmute yourself, but while the session please do not unmute yourself. We will wait for 5 to 10 minutes for everyone else to join, and then we will start the session. Uh, Let me know if my audio is clear. I am audible, right? To those who have joined. I am audible, right? Please let me know.
Yes, ma'am.
Okay, and I am sharing my screen. Please let me know if the screen is visible. Whatever you want to convey to me, please convey in the chat box, because I have turned the audio off of everyone so that no disturbance is created. We will wait 2 more minutes and then we will start the session. Please also let me know if the screen is visible. Okay, it's 6:05 now. We will start with the session. So this live session is for the subject Structure, Form and Architecture, the Synergy. It is an NPTEL course and it is being done by course instructor is Professor Shubhajit Sadhu Khan. He is an assistant professor in IIT Roorkee in the Department of Architecture and Planning currently. I am the course TA for this course. I am Shreya Shukla. I am doing PhD currently from IIT Roorkee from Department of Architecture and Planning. I have done BArch in 2018. I have done MArch in 2021, and currently I am pursuing a PhD. Today's live session we will be covering three things. First, a brief description of what has been covered in the NPTEL course in week 1. Second, previous year's assignment of week 1, which I will show the solutions with you and share my knowledge with you regarding all the solutions. And third thing would be the question and answer round, where you can ask your doubts and your questions. You can write those things in the chat box and I will answer them to my full capacity as much as per my knowledge. I am clearing this thing with everyone right now, that this is the questions that I will be solving right here or showing solutions to right here are previous year questions. They are not this year's assignments, they are not this year's questions, they are all previous year questions. So we will be only going through the previous year questions, and because this is my first session and I am doing it for the first time, I am only giving the previous year's 1 year's questions. I will see if the time permits. I will try to include more questions from the next sessions so that we can learn a lot from this session. So given the name of the course, it has four terminologies: structure, form, architecture and synergy. Before we move forward, I would like to please once explain what all these terms mean so that we can have a basic understanding before we move forward with the questions. So structure. Structure in general, the definition of structure is basically anything that is organized, anything that is systematic. It is structure. That is the basic meaning of structure. But when it comes to architecture, structure basically refers to a system which is used to support and transmit loads on the building to the ground. So basically a structure supports your building and it also transfers all the load in the building to the ground. This is what the purpose of a structure is. Now talking about form, what form actually is? Form is basically just a shape. It is a shape, it is a 3D object, it is a building envelope. Basically anything or everything that we see, every object, every building, anything that we see, there is an envelope of that building or that object. There's a 3D shape of that object which is called form. That object or that building exists in space and time, and the form of that object and the building is, and the shape of that building in the space and time is called form. And for a form, to understand the shape and the qualities of the form and the various elements of the form, it is only possible because of the play of light and shadow. What is architecture? If most of you are from the field of architecture, then you would be familiar. If others who have joined this course for basic understanding of this subject or are from civil engineering background or anywhere else or planning, architecture is basically the art and technique of designing buildings. Architecture is the art and technique of designing and building. Architecture is a science. It is not exactly technical, It is not a technological field, but it is a scientific field. So it is art and science together, which we use to design and construct buildings in the real world. Everything around you is architecture. The home you are sitting in right now, the college you are going to, your malls, your offices, your campuses, every building that has exists is architecture. Every building or everything, that is all architecture, from very small huts, from caves when it started, to now when we have such huge buildings, such huge malls, such huge shopping centers. Everything is a part of architecture. What synergy means? Synergy is basically an amalgamation. Synergy means the interaction or cooperation of two or more organizations, substances, or other agents which produce a combined effect, and that effect is greater than the sum of their separate effects. For example, I am giving an example with these terms only. For example, structure has some kind of effect, form has some kind of effect, architecture has some kind of effect. When we add all these three effects, we get a some amount of effect. But what synergy means is that we combine all these three terms together. Now, when we combine all these three things together, and then the effect that thing produces, which is a combination of structure, form, and architecture, that effect would be much more than these single effects of these terms, or if we add them separately just like that. But combining them changes everything. So that is why the term synergy is used here, because all these three terms, structure, form, and architecture, they all coexist, they all are codependent, and one cannot exist without the other. And one cannot exist without the other. So, moving forward, the course objectives, basically the course objectives of this course are to learn the relationship between structure, form, and architecture, and to understand the synergy between them, to make a synergy between them. Second objective is to know the fundamentals of structural forms, the various structural forms that are existing, their pros and their cons. And third is to learn the structural application through suitable case studies. So this entire course will cover all these points. It is an 8 week course, and we're starting with the week 1 of the live session. I will be meeting you all for 8 weeks total, as in 7 more weeks from today. Every Tuesday we will have this interactive session from 6 to 8. To people who are from the architecture field, must be aware of these three terms of Vitruvian triad. But all those who are not, I would like to for those who are not, I would like to mention about this. So, Vitruvian triad, basically Vitruvius was a Roman architect. He gave these three important terms, which he said are the basic principles for architecture, which is formitas, utilitas, and venustas. Formitas means structure, structural integrity, durability, construction quality. Utilitas means functional utility, basically the function of a space. For example, if it is a house, the function of that space would include a bedroom, a kitchen, a dining space, a garage, a washroom. The structure of that house would include slab, beam, foundation, column. And third term is Venustas, which basically means aesthetics. So, any architecture, according to Vitruvius, which is a very old, these three terms that he has given. Three terms. Excuse me, I'm so sorry. Okay, so these three terms. So formatas, basically the form, matlab the structure should be integrate, it should be robust, it should remain in a good condition. Utilitas, it should be useful and the function for people to use it. And Venustas, it should have delight people, it should delight people, and it should be aesthetically pleasing. So, this very old three terms, they also talk about the importance of structure and form and in architecture. So, from here, the basis of architecture was established using these terms, and now we would be focusing on how the structure of a building can be along can influence the form of the building, and how structure and form together are important in architecture, and how architecture is influenced by both these aspects. Moving on, now I would be talking briefly about the syllabus of week 1. So week 1 had 5 lectures. I will just outline. Week 1 had 5 lectures in it. I hope everyone has seen those lectures. First lecture was Introduction to the Structure, Form and Architecture. This basically covered the definitions, it covered the examples of different structural forms, man-made examples, man-made buildings, man-made occurring things, natural occurring things, for example, the structure of a honeycomb or a cave, etc. It covered all those points. And then this lecture talked about the process of architecture, how idea and technology is very important in architecture, what is basically the process, how you first have to articulate a space and then integrate idea and technology to it, you have to fulfill the requirements, all those points it covers. And then I will admit this person. And then it talked about the design solution. The design solution being how the design solution can be more appropriate based on feasibility, perception, and cost benefit from the angle of the user, the designer, and the developer. And then it talked about the benefit of synergy, the synergy benefits of structure, form, and architecture. So, various benefits that we get from this synergy is that it can ensure safety, it can fulfill the requirement, it can satisfy the functional need, it can optimize resources, it can solve the purpose, it can ensure the perfect fit. I am sorry, I am stopping in between because people are giving me requests to join the session. So I have to approve those requests. That's why I am stopping in between once in a while. I'm really sorry for the disturbance. We will continue now. So then it covered the benefit of the synergy, mostly safety and other things. And then we covered what are we going to learn from this course. The second lecture, relationship of structure to architectural buildings, part 1. It is divided in two parts, part 1 and part 2. So part 1 covered the explanation of structure. It covered basically a few definitions, and then it talked about the basic structures of a building, the foundation, the slab, the beam, and then we talked about structure in tents, in igloos, and then we talked about new man-made huge structures like Burj Al Arab, Burj Khalifa, and we talked about various examples. Basically, this lecture covered the skeleton and skin concept. So the skeleton and skin concept is that the structure is the skeleton. For example, your column, beam, other things, they are the skeleton. but and the walls, the finishes are the skin. So this lecture basically covered the skeleton and skin concept. And other things we covered in this lecture was the concept in architecture. So basically what concept is, it is basically a strong initial idea that actually pushes your whole design process further, and it impacts the design process. All the design decisions that we make in the future of a design process are influenced by the concept. We pick an initial idea, a concept, and then we work on that. And then we work on that. So some of the concepts that NPTEL course discovered was uh, order and chaos, stability and instability, static and dynamic structures, grounded and floating structures. And we will learn about, you would have seen the lectures and you would have understood those points. I would be covering a bit about it in the coming assignments that I would be, previous year assignments that I would be sharing with you. So, the most important thing that we learned from this lecture was the importance of form and structure, which is the synergies, how essential that synergy is, and how the concept of design can be achieved by structure. For example, you have something in mind, but you will not be able to do it if you do not have a deep knowledge of structure, if you are not aware of the different kinds of structures that you can use, the different design structures that exist. If you are aware of those things, you can make design choices based on your ideas, and you can implement your ideas into something good with the help of a knowledge of structures and the concept of design. And another thing that is very important that we learned in this lecture was that materials are also very important when it comes to structure. They're crucial for the structure and they're crucial for the form. Not all materials suit all structures, so structures are basically formed because of materials, and materials play a very, very important role. Now, in the relationship of structure to architectural buildings part 2 lecture, we covered topics of architectural qualities, and the architectural qualities that has been covered in this NPTEL lecture are simplicity and complexity, open and closed, lightweight and heavy, soft and hard, elegant and rough. And these qualities have been covered with the help of a lot of architectural building examples. And we learned from this lecture was that structural form is very important in architectural visualization quality. To visualize a thing, structural form is very important, and again material plays a very, very important role. Now the lecture 4, load on structures. So this lecture covered about different kinds of loads that exist on structures. What is a load? A load is a force on a building component or a structural component. So this lecture talked about various kinds of loads: dead loads, live loads, static load, dynamic load, point load, distributed load, uniform load, impact load, uh, which are permanent loads, which are temporary loads. And then in temporary loads we cover dynamic loads like seismic loads, flood load, rain load. Various kinds of loads were covered in this structure. And why we have covered this, excuse me, why we cover these many loads is because we need to be aware of the different kinds of loads that exist. We need to be aware of the different kinds of the loads that exist so that we can design optimally for those conditions. For example, if you are designing for a building in a place which is earth, where a lot of earthquakes happen, you need to be aware of the earthquake load in that area so that you can design your building in such a way that when and if an earthquake occurs, that building does not collapse completely, the structure could carry on the load and transfer it to the ground with minimum damage. So this is why we should be aware of the different kinds of loads that exist, and so that we can design optimally. That's why we covered the different kinds of loads on structures in this part. The last lecture was about the synthesis of architectural and structural form. So this lecture started with covering all the different kinds of definitions for form. What is basically form, which I have just discussed with you. What is a form, and then what is architectural form. What is meant by architectural form is basically the 3D envelope of a building. Architectural form. What is a structural form, in which we learned that the more appropriate term to be used would be structural system, not the structural form, for to understand it. Then we learned about the 4 S's of structure, which are synergy, strength, stiffness, and stability, and how all those 4 things matter with respect to structure. Then we learned about various architecture and structural forms, basically how different structural forms, structural systems are being utilized as building forms. And these are very advanced technologies. We are living in 21st century, and we have such advanced technology at our hands, such creative people, such technological people now, and we have been making all these innovations in design. And that's what we learned in this lecture about different kinds of structures. Which are structures, they are supporting the building, they're taking the load of the building, but they are also in different kinds of forms. They are looking aesthetically pleasing, they have a dynamic form. So they are not only supporting the load, they are looking architecturally good too. So we learned about those kinds of systems. For example, we learned about shell structures, we learned about fabric structures, we learned about catenaries, ribbed structures, arches, folded plates, framed structures, walls. We learned about all those structures. I will Now, moving forward, we would be doing the previous year questions. And again, I am clarifying it that these questions are the previous year's assignment questions. They are not this year's assignment questions. I will not be solving this year's assignment questions. I will be only solving previous year assignment questions to help you with an understanding of these assignments and these questions, and to help you with this NPTEL course. We will today I will only cover last year's assignment questions, and if time permits, from if I will understand how much time everything will take, and if time permits, from next session I will try to cover 2 years questions, so that I can cover maximum questions for you all. And I will this session I am only covering assignment 1 questions. Next session I will try to also cover the week 0 questions of last year. I'm again clarifying, I will only be covering the last year questions, not this year questions. And please, in the questions that you are going to ask me after this session, please do not ask me the solutions for this year's questions. You have to go through the lectures and then do it. I'm only here to help with your doubts and other things. I will not be solving this year's assignment questions. So the first question is, where is Statue of Unity situated in? So I think most of us would be aware that Statue of Unity is in India. But here are some of the few facts about Statue of Unity to keep you in that you can keep in mind, so that you further remember all the important aspects and points about this monumental statue. So first thing is, it is the world's tallest statue currently. It is currently the world's tallest statue. It has a height of 182 meters, which is 597 feet. And you can see in this figure that I have put right, in on the right side, that Statue of Liberty is 152 feet. There is a small projected diagram of Statue of Liberty next to it, and you can see that this Statue of Unity is 597 feet. It is currently the world's tallest statue. It is a statue of our Indian independence activist Sardar Vallabhai Patel, and the construction of this statue started in October 2013 by Larsen and Toubro, LNT, commonly known as. I hope everyone is aware of LNT. It's a huge construction company and it employs architects, planners, civil engineers, and this has been constructed by LNT. It took 3.5 years to complete the structure, and the total cost that was spent on the structure was 27 billion, and it was designed by the Indian sculptor Ramvi Sutar, and it was inaugurated on 31st October 2018, which was the 143rd birth anniversary of Sardar Vallabhbhai Patel. So, other important points about this, because we are learning about this from the point of view of the structure. So, it has a center of cement and concrete. There is 2100,000, 2 lakh 10,000 cubic meters of cement and concrete in the core of this statue, and 6,500 tons of structural steel is used, and 18,500 tons of reinforced steel is used. If you can see the figure on the right, you can see that there is a core. This is the core, which is excuse me. So this is a core made of cement and concrete, and then you can see that these are horizontal structural struts made of steel, which are providing the shape of the body, if you can see clearly in this diagram. Now, after the structure was done and the struts were provided, like you can see in this image, these are the struts that have been provided, and then the facade was cladded with bronze plates. So, 1700 tons of bronze plates were used, and 1850 tons of bronze cladding was used. So, first we created the concrete core, then we created the shape with the help of horizontal struts, and then we specially designed each and every bronze cladding bronze plate, and then we assembled it all together to form the statue. So the question was that Statue of Unity, where is it situated? It is situated in India. The Statue of Liberty, which we saw in comparison here, it is located in New York. It was gifted to America by France, Paris, and there is another statue similar to this in Paris existing. That's why these options were given. I'm so sorry, I'm not very well. I'm still trying to do my best. If someone feels like my voice is not very audible, please just let me know. You all can message on the you all can message me on the chat after where I am done with all the questions. You can ask your questions. I will try to answer them to my full capacity. Moving on to the next question. TWA Airport Terminal in New York City is inspired by the form of a kite, ant, butterfly, or bird. So, to proceed, I am giving some information about the TWA Flight Center. TWA Flight Center, or the Trans World Flight Center, it is an airport terminal and a hotel complex at New York City's John F. Kennedy International Airport. It is not an airport itself, like airport terminal. It is a airport terminal and complex at New York City's International Airport, JFK Airport at New York. It is a part of that small part of it's there's a small airport terminal on that complex. So it is that. So it was designed by the famous architect Eero Saarinen, and it was inaugurated built in on May 28th and 1962. 1962. So when you see this picture, what do you think that it is formed of? What is the form of this building? What are you reminded of? Again, we will go back and see the options that we have. So the options that we have are kite, ant, butterfly, and bird. So again, looking at this picture, what do you feel like the building is inspired from? Which animal or creature it was inspired from? It is very evident that it was inspired from a bird. So the design philosophy that the architect Eero Saarinen used, these are some of the Uh, I will take the questions after I am done with the assignments. I see Akansha raising her hand. You can leave your question or doubt in the message, and then we can talk about it later. Thank you. So, the the design philosophy that the architect used was to actually uh, give this concept that it looks like a giant bird was ready to fly, and he chose a bird because he wanted people to be associated with the idea of flying. So that's why it rests, the building is like, it feels like it rests on a ground carefully, and it looks like as if it is a giant bird and it is ready to fly at any time. And the whole building has been made of reinforced concrete, and it represents the metaphor of flight. The philosophy or the ideology or the concept of the architects was to represent the metaphor for flight. That's why he chose a bird, and then he executed this form, and then he got this whole thing built. So the answer is D, bird. Third question, which of the following building represents visually floating in architectural concept? So first I'll show the images of four buildings. So these are the four buildings. First is the Haider Ali Center in Baku, Azerbaijan. It was designed by Zaha Hadid, and it is a cultural center of the country. It's very famous. It's a very famous building. Zaha Hadid is a very famous architect who plays with curvatures. Second is the Farnsworth House, Plano, Illinois. Third is IM Ahmedabad. And fourth is the Rolex Learning Center, Lausanne, Switzerland. So again, the question was which of the following building represents visually floating in architectural concept? So I have shown the images of four buildings, but to answer this question, we should be aware of the concept of visually floating. So now I will talk about that. So as I mentioned before also, the architectural concepts covered in this NPTEL course are order and chaos, stability and instability, static and dynamic, grounded and floating. So what is a floating structure? So basically these are architectural concepts. The structure is not actually floating. It may also be floating with the help of cantilevers, but it also includes structures which just give a sense of floatingness. For example, that it feels like it's floating because there is gap between the ground level and the plinth level of the building, or there is minimal support with narrow columns, so it looks like it's floating in the structure. It could be heavily cantilevered, that's why it can look floating, it can give a sense of floating. Or there is a heavy mass that is above, and there is a narrow and small vertical structure that is holding that heavy mass, that also gives the sense of floating. So a sense of floating is provided by uh, these kind of structures. And floating is actually the opposite of grounded, where you feel like the building is grounded, it's sitting on the ground. Grounded means sitting on the ground. Floating means that it feels like it's floating in the sky, it's floating a little above the ground, it is somehow in the air. So again we go back to the question. The question was that which of the following these four structures represent visually floating an architectural concept. And then we looked at the buildings. And when we look at the buildings, so Hyder Ali Center in Baku and IIM Ahmedabad and the Rolex Learning Center all are sitting on the ground. While when you look at the Farnsworth House in Plano, Illinois, you can see that the house feels like it's floating in the air because it is supported on such thin columns and there is a gap between the ground and the plinth level. It feels like it is floating. I have a bigger picture. If you can see this picture, you can see very clearly how this looks like a floating house. And it is looking floating because of the narrow column and the gap near the ground level, which lessens the physical and visual connection of superstructure to the foundation, and it results in a sense of floating structure. So basically there is a physical and visual connection between the superstructure and the ground. It is very less. If you can see visually, we are feeling like the connection between the ground and the plinth is very less, the superstructure is very less. So physically be it's less, visually also it feels very less because the columns are so narrow. And it was designed by Mies van der Rohe from 1945 to 1951. It is located in Plano, Illinois. It was built on a 100-acre site as a holiday home. So the correct answer is Farnsworth House, Plano, Illinois. Coming to the next question. Which of the following, one second, I'll just check if somebody has any questions. The detailed quantification data. I'm sorry, Akansha, I didn't properly understood your question. Once we're done with the, okay, can you please, I didn't understand your question. What are you trying to ask me? What is to be known for the examination purpose? Yeah, please speak. Right. Yeah, I'm unmuting you. Wait. Yeah, you can turn your mic on now.
Yeah, yeah. Hi, ma'am. Thank you for the question answering. I was inclusive regard the details which you have shared as an exemplary thought. And on the first two questions, like the Statue of Liberty, or you were explaining the second question, you
Yeah, yeah.
also enlighten us with the further extensive details of the specific structures.
Mm-hmm.
So my question, like those specific and detailed numerical values and data in terms of date and what are the detailed specification of those respective structures
Mm-hmm.
are also be part of like our, it's really good to be enlightened and we should be aware of those things, but it's really very hard to be mugging or gulping all those details, that level of detailed answers for every next structure which we are coming across. So that my worry was like, well, that category of question will be in the examinations. I mean, sure you don't know that. It's just a worry
Okay.
of mine because
No.
it's really each and every aspect of every structure.
Yeah, yeah, yeah. I understand your point. So no, these are basic points or important facts about buildings that I'm giving, so that if you know these points, you will remember those things about that building. Sometimes we remember facts about buildings which helps us recalling. So that's why I'm adding pictures and I'm adding details about it, so that if you come across a question in which you feel confused कि ये if this is what that is, you could remember that it was something like that I had seen in that presentation. It is just for that purpose. The questions that you will get in your exams will only be based on what has been covered in the NPTEL course videos that you have seen. It will not be
No, that's
based
what.
on what I'm teaching. It will not be based on what is happening here. I am just here to clear the doubts and solve the previous year questions. The details I share will not be a part of it. The questions will only be based on what is being covered in the NPTEL course structure, the videos that are already there.
The more talking about the concept and the I think the theory based part, how the structures and the other concept the sir has evolved, rather than focusing on the numeric terms and values, like which you have probably you're right in saying that if we remember those key points we might memorize in the examination. That makes
Yeah,
sense. Yeah.
yeah,
Thank you.
yeah. Just yeah. So we'll continue. So, which of the following example represents the order in architectural concept? So, we have four buildings given here: Parthenon, Royal Ontario Museum, Bird Nest Olympic Stadium, Gas Natural Headquarters, Barcelona. So, I've added pictures of again all the four buildings so that you can remember or understand what those buildings are like and then able to answer the question. So Parthenon, we all very well know. Those who are from the architectural background would be aware of this building from your history of architecture classes. So Parthenon. Second is a Royal Ontario Museum. Third is a Bird Nest Olympic Stadium, which is a stadium in Beijing. Fourth is Gas Natural Headquarters, Barcelona. So again, the question was that which of the following buildings represent order in architectural concept. So as I have mentioned that sir has covered different kinds of points. So the various architectural concept points that he covered were order and chaos, order and chaos, stability and instability, static and dynamic, grounded and floating. So, what ordered looks like? So, order is basically anything in a systematic form. So, when you think about systematic form, and then when we talk about all these buildings, if you look closely, you'll see that the gas natural headquarters, there is a huge cantilevered floating structure. The Royal Ontario Museum, you can see there's a combination of two things. One is very chaotic, very new kind of thing amalgamated with the old structure of a building. And then you see a very dynamic form in the Bird Nest Olympic Stadium. And when you go to Parthenon, you see very ordered columns, all arranged at equidistant form. Everything is very organized, everything is very structured. So the Parthenon is structured in the form of its plan. It is structured, it is ordered in the form of its elevation, in the form of its view. So it is a example of an ordered structural form. So the answer is Parthenon. Moving on to the next question. Uh, which of the following is representing simplicity in architectural quality? So simplicity is again one of architectural qualities that has been covered. Are I'm so sorry. I'm so sorry. So the architectural qualities that have been covered in the NPTEL course are simplicity, complexity, open closed, lightweight heavy, soft hard, elegant and rough. So the question is asking which of these following buildings is representing simplicity in architectural quality. So these are again the four buildings that have been mentioned. Harbin Opera House, China. It's an opera house, it's a theater located in China. Villa Savoy, Paris, France. Villa Savoy is a villa in the outskirts of Paris. Eiffel Tower, Paris, and Dongdaemun Design Plaza, Seoul, Korea. So the question asks which one of them is representing simplicity. So simplicity basically means the elevation is simple, the form looks regular, it looks simple, and both sides are looking simple, both sides feel connected, nothing feels very dynamic, no curves. It could be curved, but it feels very simple. So again, when we go back to these images, you can see that the Harbin Opera House has a very dynamic form, very different than what we see. Same with the Design Plaza in the Seoul, there is a lot of curvature going on, and the are not very harmonized, all the sides of the plaza. And then when you look at Eiffel Tower, you can see that how complicated the structure looks. It is symmetric. It is definitely symmetric, Eiffel Tower Plaza, but the structure is complicated. It is not simple. It is not regular. It is not something super plain. So we come to our building, Villa Savoy in Paris, France. It is a modernist villa. It was built by or designed by Swiss French architect Le Corbusier. I hope everybody is familiar with Le Corbusier's works. It was built between 28 and 31, and it was built using reinforced concrete. Le Corbusier gave 5 points for new construction in architecture, which he said that any kinds of new architecture in international style should have these 5 points. And then he designed this house which covered all those 5 points. So it has become a huge big example of the 5 point of Le Corbusier's new construction architecture. And the 5 points are the use of pilotis, which is the use of pillars. You can see how in ground floor there are thin narrow pillars. Second is a roof garden. So this villa has a roof garden. Third is a open floor plan. You can see how in open floor plan basically means that there are no walls. The floor is open. There are structural members, and then you don't have walls really doing that. Then the use of long windows. You can see the first floor, the whole ribbon of a long window. It is called ribbon window. So you can see that. And open facades. For example, you can see how in ground floor the entire facade is open. So this is an example of Le Corbusier's famous 5 points of new construction, and it is also a renowned example of the international style. And you can see very well from the image, both provided here and here, that it is a very simple or a regular looking house. So that's why it is an example of the simplistic form of architectural quality. So again, the question was, which of the following is representing simplicity in architectural quality? So the answer is Villa Savoy. I'm sorry, I'm taking a 5 minute break. I will rejoin in 5 minutes. Hi everyone, I'm back. I'll start with the next question. So, which of the following is representing visually closed form in architectural concept? So, the four buildings that have been given are Frankfurt International Airport Terminal, Swarnabhumi International Suvarnabhumi International Airport Bangkok, Louvre Museum Paris, and Bihar Museum Patna. So I am again showing the four images of the four buildings that have been mentioned. First is the Frankfurt International Airport Terminal in Germany. Second is the Swarnabhumi International Airport in Bangkok. Third is the Louvre Museum Paris, and the fourth is the Bihar Museum. The question asks that which of the following is representing visually closed form in architectural concept. So we need to understand first what does visually closed form really mean. A visually closed form is an architectural quality, a sense of closed form, and it can be achieved with the use of closed plans. Where, for example, you can see in these buildings how other buildings how the form is open because of the use of material frame structures like this and glass like this. It feels very open, very light. It does not feel closed. So a closed form means that the plan is entirely closed. You don't feel the openness. You feel that it is closed. It is categorized with high walls. Some examples of a closed form would be IIM Ahmedabad, the Jawahar Kala Kendra. I'm giving some Indian examples to you. And visually closed form is basically the opposite of sense of visual openness. For example, what this means is visual openness can be achieved with the help of open plans, uh, use of a lot of glass, and other things. And closed form is achieved with the help of high walls and a closed plan. So when you look at this picture again, it is very clearly visible that all the that the three buildings have a lot of glass used in them, and they feel very open. They feel very a lot of daylight is coming in. They feel very open. And when you look at this building, the Bihar Museum, this is located in Patna, Bihar. It was designed by Maki and Associates. Maki and Associates are very famous Japanese architects. The area is 25,410 meters square and it was built in 2018. So when you look at this building, and when you compare it with other all these examples, you realize that Bihar Museum is actually closed and all these others are open. So the correct answer is the Bihar Museum. So it is a very visually closed in architecture. The architectural concept that has been used in this building form is that it is very visually closed. It is characterized by a lot of walls. There is not a lot of glass used, not of open floor plan used, so that it becomes it characterizes with openness. It is characterized with closed. I'm really sorry. Speaking so much is triggering my throat. I'm already not well. I'm really sorry for the disturbance. So, question number 7. So, below are the some of the examples. This question came up with the images. I have not added these images. This question came with the images. This question is asking that which of these buildings represent visually lightweight in architectural qualities, and then they have given various options that only first is representing that, or second and third is representing that, or second and fourth is representing that. So to answer this question, you should be aware of the again this term, which is visually lightweight. So visually lightweight is again one of the architectural qualities. It is the opposite of heaviness. So what is visually lightweight in architectural quality? It should feel light when you look at that building, when you look at that some object, anything. You should not feel a very heavy mass or solidness. So it should feel light. It should be visually feeling light in the interior form. It can have a column free space. For example, a column free space feels very open. It feels very light. So we're looking for something like that, which when you look at it, it feels light. It doesn't feel heavy. It doesn't make you feel like, oh, it's congested, it's heavy, this is so huge. It feels light, it feels open. It is basically the opposite of visual heaviness. So again, going back, when we look at these buildings, so when you see the first building, I'm forgetting the, I'm sorry, I'm forgetting the name of both the other buildings. Third one is the Frankfurt airport. Second one is a stadium in Beijing, if I'm not wrong. So, yeah. So when you look at these buildings, the first building and the fourth building, you can see how massy they look, how heavy they look, how solid they look. They look very heavy. While when you see the other two buildings, the second stadium, it feels very open, it feels very light, and similarly the third image, which is of Frankfurt airport, it is it is just feeling light looking at that compared to the image in fourth and one. When you notice this, you realize it. Why it is feeling light? It is feeling so light because of a lot of daylight coming in, a lot of the use of a lot of glass in it, the presence of no columns in the whole area. The entire space feels free to walk in. It is not supported by huge columns or heavy columns. So the correct answer is C, second and third, the stadium and the Frankfurt International Airport. And I'm forgetting the name of the other two. First one is a museum, and the second and the last one, it is actually a church somewhere, but I'm completely forgetting the name right now. Moving on. Moving on to the question number 8. So, the question number 8 was the point under the earth's surface where the earthquake originates is called epicenter, hypocenter, fault center, or ground zero. So why this question is here in this subject is because we covered an entire lecture on various kinds of loads. So in which we learned that there are permanent loads and there are temporary loads, and then there are various kinds of temporary loads, which are imposed loads, thermal loads, and dynamic loads. And then there are a lot of kinds of dynamic loads. A dynamic load is basically anything that is varying and that is not permanent, and that comes with circumstances. So in the various examples of dynamic load, one of the load that we covered was seismic load. And to understand seismic load, we should be aware of a few of the terms that are associated with seismology. Not that we should be aware of it in super detail, but some of the few terms, and some of the design implication and some of the structural implications, so that we can take a informed designs decision. So I'll explain all these four terms. Uh, so what is an epicenter? An epicenter is basically the point on Earth's surface, vertically right above where the focus of the earthquake is. For example, there is a focus, the earthquake occurs at a point, and then imagine there are ripples coming out of it. So when the circle of that ripple touches the surface of the earth right above the focus of the earthquake, that is called epicenter. What is hypocenter? In seismology, a hypocenter is the point of origin of an earthquake. It is the focus of the earthquake. Third term that was in the question was fault center. So there is nothing exactly like a fault center, but there is a thing called fault line. So a fault is basically a fracture or zones of fractures between two blocks of rock, and Faults basically allow the blocks to move relative to each other, which is the reason of a earthquake. So the center of the fault line is the most deformed, and it is where most of the offset or slip between the rock occurs. Then ground zero. The term ground zero and surface zero are used in relation to earthquakes, epidemics, and other disasters to mark the point of the most severe damage or destruction. So, ground zero means the point where there is the most severe destruction because of the earthquake. So, we learned about both all four of these points. So, again, the question was that the point on under the Earth's surface on, it's not saying the point on Earth's surface, it's saying point under the Earth's surface where the earthquake originates. So, the correct answer is hypocenter. Question number 9. So ringing a church bell repeatedly can create settlement load, not sentimental load, resonance load, impact load, or thermal load. Again, all these resonance are part of dynamic load, which I just mentioned when I was explaining the earthquake point. So settlement load and resonant load, they both are dynamic. Impact load, they both are dynamic loads. And thermal load is actually a kind of temporary load, but it is not exactly a dynamic load. So, to answer this question, we should be aware of all the terms so that we can know which one to write and which one to not. So, the full terms are sorry, settlement load. So, settlement load basically means all the load that I'm saying here, the word load that I'm using here, these are all associated with your building, and these are all kinds of loads that are associated with a building specifically. So, settlement load is basically what happens when one part of there is a building which is resting on a surface. So, one part of the building settles more than the other parts. So, this load occurs, and this happens when the ground collapses or the ground goes in a little because of a faulty line, or it could be any other reason because of faulty foundation. There could be many reasons for that. So one part of the buildings goes in and the other part stays up, because of which the building distorts. There can be a lot of damage. This is what is settlement load. Resonance load. So resonance is a phenomena in which an external force or a vibrating system forces another system around it to vibrate with greater amplitude at a specified frequency of operation. So the resonance load can occur in a building if something with a frequency forces the building to also vibrate on an amplitude in that specified frequency. Impact load. Impact load is defined as the force provided by a sudden load on a structural part instead of a constant and sustained force applied over a longer time. For example, impact load is basically when there is a sudden load. It was not being implied, and it was not predicted or anything. It was a sudden load. There was a sudden load on a structural part which we were not aware of. That is called impact load. The examples of impact load are basically car crash. When car crashes in something, so that surface experiences impact load. When you hammer a nail on a wall, so your there was no load on the wall, and then when you started hammering on the wall, a nail on the wall, so you're creating a load on it. Or dropping a sudden weight of something on the floor. The floor was accounting for all the other kinds of live and dead load, but then suddenly dropping something on the floor. All these are examples of impact load. Then thermal load. Thermal load is defined as the temperature that causes the effect on buildings and structures, such as outdoor temperature, solar radiation, underground temperature, indoor air temperature, and the heat source equipment inside the building. So, what thermal load does is actually uh, so with heat or with cold, we know contraction happens and expansion happens. So, what happens in thermal load is that uh, imagine there's a lot of heat and there are different kinds of materials that react to that heat differently. So one of the materials is expanding because of the heat. So that material is expanding, it is taking more space than it was supposed to take, which causes a lot of damage to the building. Similarly, when there is a lot of cold temperature and some kind of materials contract in that cold temperature, some kind of materials contract in that cold temperature. So again, some kind of damage will occur. The lines would shift, the stability would shift. That is a thermal load. So the question was that the ringing a church bell repeatedly can create which of all these four kinds of loads. So when you talk about bells, bells are basically, a church bell is like a shape of a hollow cup, and when you strike that bell, it vibrates, and because it vibrates, it resonates. So because when we struck a bell, it will resonate, it will create a resonance load on the building. So that is why the answer is resonance load. Last question. Paul Klee Museum is an example of arch structure, membrane structure, shell structure, or folded plate structures. These all kinds of structures are covered in the lecture 5 of week 1 lectures. So before we go forward, we will see what actually, how actually Paul Klee Museum looks like. So this is a museum that has been dedicated to Paul Klee. He was an artist, and 60% of his work has been displayed in this museum. This museum is located in Bern, Switzerland. It was designed by the famous Italian architect Renzo Piano, and it is characterized by the structure of corrugated steel deck in the form of arches. So the four terms that were given here were arch structure, membrane structure, shell structure, and folded plate structure. So we will understand about all four kinds of structures to be able to answer this question. So arch structure, so we all know what an arch is. So mostly everybody knows what an arch is. So arch is a vertical curved structure that spans an elevated space and may or may not support the weight above it. Arches can support the weight, arches may not support the weight. But when we are talking about arch structures, so this entire structure is basically in the shape of an arch, which can be semicircular or parabolic or pointed, but they have a single kind of convex curvature. But these arch structures, so an arch, when it is a part of a building, so it can be ornamental also, it may or may not carry the load. But when we are talking about an arch structure, then the arch as a shape becomes the structure, so the structure is taking the load in this case. What is a shell structure? A shell is a type of structural element which is characterized by its geometry and being a 3D solid. Its thickness is very small when compared to other dimensions, and it is basically a curved plate structure shaped to transmit the applied forces on it, all the compressive, tensile, shear stresses that act on the plane of the surface. So shell structure is basically a very thin sheet kind of thing, which has a very dynamic 3D kind of shape, and it takes all the kinds of loads on it, and they're usually constructed of they're usually constructed of concrete reinforced with steel mesh. What is a membrane structure? So structures with a thin flexible surface, which is called a membrane, that carries loads primarily through tensile stresses. There are two main types of membrane structures, which are called pneumatic structures or tent structures. They're also called tensile structures because they transfer the load through tensile stresses. And then a folded plate structure. A folded plate structure is a set of flat plates that are inclined in different directions and joined along their edges at the top. This type of structure is beneficial because it's capable of carrying loads without requiring the use of additional support beams. So we learned about all four kinds of structures. So again, going back to the image, to be able to answer these questions, you should be remembering what those buildings look like. Otherwise, you will not be able to really answer these questions. So when you look at this building and you know all four kinds of structures that we talked about right now, there are other kinds of structures also, fabric structure, rib structure, arch plates, frame structures, and other things. So now when you look at the structure, you realize that there is a curvature, there is a corrugated steel sheet kind of thing that is going on in the shape of an arch. So then we realize that out of all the four examples that have been given here, this is an example of an arch structure. So we still have some time left, and this time is basically for the question and answer round. If anybody would like to ask any question or anything from me, you can type your question in the chat window. Please don't turn your mic on because that will create a lot of disturbance. I will see your question in the chat window and I will try to answer it. If I am not able to provide you with an adequate answer at this moment, I would provide it in the next live session when everyone, all of you will join. So the 10 questions end here, and I have realized that we have some time left now still. So in the next class I would try to include a few more questions from each lesson, at least 5 more, so that you can have a practiced session. So now question and answer time. It's about doubts. You can ask me about it, then we can end the session. If anybody has any kind of question, I'm here. Please type your comment. Please type your question in the comment box and I would try to answer your question. We will keep this portal open for 15 to 20 minutes more. If anyone has any questions, please kindly put it in the chat box so that I will answer it immediately if I have the correct answer with me. If I do not have the correct answer with me, I would answer it in the next session. Any doubts, any questions you have, you can please put it in the chat box. So Rishi has asked that during exam the pictures will be shown or else we have to answer it only with the options. Oh, sorry, I'm so sorry, I was muted. So Rishi has asked that during the exam the pictures will be shown or we have to answer it with options. So like I showed in this one example, uh, this this one question, this was the only question that was in the previous assignments which had the picture attached with it, so you can see an answer. But others, I have added those pictures for your understanding so that I could explain it in a better way and so that you could understand. So some question might have pictures attached with them, but most questions will not. But all the examples that have been covered in these questions, as far as I have noticed, have actually been covered in the NPTEL course. So if you're taking the course, you will understand that, you will realize that these examples are there. So I think you will have to memorize these examples. You have to learn these examples of each kind of quality or form to be able to answer these questions. Because you have to remember how this looks, how the form looks, how the structure looks, to be able to answer those questions. So these are very famous buildings around the world. So that I think you will have to memorize, because some questions might have pictures associated with them, but some might not. Sure. We will stay on the call for 10 minutes more in case anyone has to ask any question. I will end the call at 7:45, and for the next class I will try to sorry, I was again muted. We will stay till 7:45 on the call, seeing that there are no questions are coming. Uh, for the next class, I will try to incorporate more questions so that we can utilize this time and it is not uh, we do not just wait for people to ask questions. So from next time I will include more questions about it. We will wait for 10 more minutes to see if anyone has any questions, if anyone would like to include any questions. We have waited for questions, and because no one has asked any questions, and have given considerable amount of time to ask your questions, I would like to end the session. And seeing that we have some time left in this session, I will make sure that we utilize the next session well. I will put in more questions. So, thank you everyone for joining. If you have any queries, any questions, you can email me and ask me, or you can ask it in the next session. Thank you so much.
Thank you, ma'am.